let's have a look at something now called the browser document object model. We've discussed that different objects are available in our scripts depending on where the code is executed. I want to, in particular here, consider the objects that are available within the browser, the way in which a browser processes the HTML of a page, and the need to allow script to interact with the HTML structures means that the scripting engine within the browser needs to have a conceptual model of the different tags that make up the page, and we call this the browser document object model. So the document object model is part of the programming API for any HTML documents within the browser. And it's based on an object structure that closely resembles the structure of the documents it describes. Now, HTML is a subset of XML. It's a subset of that family of markup languages, and it has a very logical structure which can be imagined as being like a tree, or rather a collection or forest of trees, because a document can contain more than one tree. A document can contain multiple forms. Each form contains multiple fields. Each field can be of a variety of types and can have values within it. We use the term document object model to describe this tree-like representation of a document. We also use the term tree when referring to the arrangement of the information which can be reached by using tree walking methods. So you can walk up a tree by going from a field up to its form, from the form up to the document, from the document to the window, and then back down again. Or we could go all the way up to, if you've got an iframe contained within there, we can go up to the top document, then down into the iframe, and so on. We can walk the tree. When we open something like an opportunity summary page in Sage CRM, then in the browser we're going to have a document that will have a form that contains fields of type text or hidden or select. And the same document will also have hyperlinks and other tags which we can access and control using JavaScript. I'll give you an example. Here is a simple OnChain script within the definition of a workflow rule. You'll notice that in the script it uses the keyword this to check the properties of the current object within focus. Now we happen to be writing this for the field opportunity certainty, so the this refers to the object opportunity certainty and then allows us to access any of its properties, which include value. So this business rule is checking whether the certainty has been set higher than the value allowed at this point within the workflow process. We'll look at operators and comparisons in a moment. But in the interface, this results in a message displayed on screen when the conditions are breached. We can see that the value is automatically corrected as well to the maximum value allowed. So let's have a look at this as the code. This is the code that I used. The way in which an on-chain script works is that when the field content changes, then the event fires. Your code can only access browser objects within a on-chain script, but you can have full access to the document object model and the object's specific properties. Now, in this case, I'm using value of the field. But we can also use any other objects and functions that exist inside the browser, and that includes custom libraries of objects, which contains, in this case, the CRM object is one such custom object that forms part of the Sage CRM client-side API. Okay, let's expand this to the idea of binding scripts. On the screen now are two examples of writing out a phrase in an alert. In the first example, the JavaScript is executed when it's loaded into the browser. In the second, a function from the client-side API is used. Now, this allows you to ensure that the script is executed when the page is fully loaded, so all objects can be found and controlled. It actually binds the execution of the code to the completion of the onload event. So if you like, it only executes once the page is fully in the browser. And the function is a unit of reusable code, and because it's attached to the onLoad event, it means we can now access any data or objects that have been loaded into the window. Switch back into my browser. Here I'm looking at an opportunity summary screen. Each browser that we use, Chrome, Internet Explorer, Firefox, have tools that allow us to examine the structure of the page and then experiment with interactions with those objects. Now I happen to be using Chrome, and to access the developer tools I press F12, so that's function key 12. And I've just opened this up and I can explore the HTML that makes up the page, or I can zoom to an individual element by right mouse clicking on a field and selecting inspect. So if I go on to inspect, this allows inspection of the HTML that causes the screen to draw this element. Now in this particular case, you can see how I've highlighted something that is a span with an ID that says data oppo description. See how the field in this case has span tags which define the caption and the data for the field. These span tags each have a unique ID, and if you've got a unique ID, they can be easily controlled using JavaScript. Sage CRM puts standard IDs around all captions and data for fields. So comp name, for example, can be identified by saying _data comp name and _capped comp name. And this is an address that can be used by custom content scripts or by OnChain scripts. And we can access the field and any of its properties, and we'll explore this later in the lessons that make up the full sequence of advanced customization lessons.